All right, good afternoon, everybody. I hope you're enjoying your Friday. In this particular video, I'm going to talk about the law of sines and law of cosines. And in doing so, I'm just going to work two problems from your assignment or practice problems that I handed out yesterday. So if you pull that out, I got problem number 2 I'm going to work and problem number 5. Obviously, the problem number 5 deals with the law of cosines, and number 2 allows us to use the law of sines. Now, as you work with these problems, the law of sines is probably the easier of the two if you kind of look at the formula for the law of cosines. And I kind of make note here, and I want to prove this when we work problem number 5, is you only have to use the law of cosines once when you are not given a side length and its opposite angle. Okay? So on this first problem, you'll notice that we're giving a side length and its opposite angle, and so therefore we don't have to use the law of cosines on this particular problem. And so we're able to use the law of sines because we have a side length and its opposite angle. In this case, we have angle A and side A. All right. Notice how we have two equal signs in this. So this formula is just saying that we can compare whether we're given side A, sine A, whether we're given A, B, or C. It doesn't really matter. We can compare any two. So I could compare A over sine A equaling C over sine C. So it really doesn't matter which order you use. So essentially what we're going to do is set up a proportion. So if we're working problem number 2, we have, side A is 14 over sine 137 equals I'm going to try to find this side, AC, or side B. So that would be B over sine 17. All right, so make sure when you're working this problem that you're in degrees on your calculator. By pressing mode, you can see that whether or not you're in degrees or radians. You should be in degrees, but just make sure you switch that over. All right, so how we do this is we're going to multiply across, essentially making the two fractions equal to each other. So we have 14 times sine 17 equaling B times sine 137. All right. So what we have here is 14 times sine 17. So we get 14 times sine 17, which you should get something like 4.093203, blah, 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 blah. Okay. And so with that number, we have, we're going to divide that by sine 137. Let me just give a quick reference to make sure you guys are typing it in correctly. So 4.09 equaling B times sine 137. And so now what we're going to do to solve for B is divide by 137, divide by sine 137. So we're going to keep that number inside there, and we get divided by sine 137, and you should get a decimal of 6.0001779631. Okay, so what we get here is 6.0017 blah 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 equaling B. Okay, so the side length of side B, I'm going to round that to the nearest tenth, as it says in your directions, and that is 6. Okay. Now, there's some other things that I can know about this, because if I'm giving two angles inside the triangle, I know that angle C is the answer of taking 180 minus 17 minus 137, and so we get, let's see, 180 minus 17 minus 137, and so we get 26 degrees. All right, so I know just by my knowledge that inside a triangle is 180 degrees, that this angle right here is 26 degrees. Okay, so essentially what I'm doing is I'm solving the triangle, meaning I'm finding all side lengths and angle lengths. So I have one left, and that is side C. So in order to find that, I'm just going to take my original side A and angle A. So I'm going to take 14 over sine 137 equaling, let's see, my angle here is 26 degrees, so I'm going to take side C and sine 26 degrees. And so if I do the same math I just did, I get 14 times sine 26 degrees equaling C times sine 137 And essentially what I'm going to do is take 14 in my calculator, 14 times sine 26 divided by sine 137, and I should get, if you did that correctly, is 8.99988. So I did that all in my calculator, so make sure that you get the same answer, equaling C. Now if I round that up, I get 9 equals C. Okay, so this side is 9. So essentially what I did is I just used the law of sines the whole time, because I was able to have, I was originally given a side length and its opposite angle. Okay. Now also notice, to make sure you're doing this right, is we notice that the side opposite this side is 137 degrees, so that would be the largest side of this triangle. This is 17 degrees, which is 6, and then 26 degrees gives me 9. So I'm reasonable to say that these are the proper lengths, because it's proportionally pretty good, because 26 degrees is in between 17 and 137, 9. You kind of get my point there. All right, so now let's talk about a situation where you're not necessarily given a side length and its opposite side. And like I said in right below the law of cosines, is the idea that you only have to use the law of cosines once, because once you use it once, you have a side length and its opposite angle, in which you can just start using the law of sines. Okay, so I'm going to do this rather quickly, but pay close attention as I'm working through this problem, because the biggest problem people have with this law of cosines is this little negative sign right there. Okay, so it has to really do with the, well, we don't want to do that again. It really has to do with the order of operations here. So for example, we are giving a angle, and we're giving a side length, side length. So essentially this is a side angle, side triangle. Okay, so let's try to figure this out. We're given, we're trying to find side C. Okay, so in doing so, I kind of look here and I say, all right, I want to know side C, because if I find side C, then I'm given an angle measurement and its opposite side, which then I can just go right back to law of sines, which proves my idea that you only have to use the law of cosines once. All right, so let's work through this problem. We have C squared equals, and as you notice with the formulas, you can pretty much use any one of them. They're all going to be the same type of idea here. Okay, so we have, and you'll notice it kind of looks familiar with the Pythagorean theorem, but we'll kind of talk about that in class. So we have C squared equals, side A length is 18 squared plus 11 squared minus 2 times 18 times 11 times cosine 119. Okay, and so what I'm going to do is some math here. 18 squared is 324 plus 11 squared, which is 121, minus 2 times 18 times 11 times cosine 119. I'm just going to type that in my whole entire calculator. And essentially what you can do is type this whole thing in your calculator. But I'm going to get 346.349 blah blah blah. Okay, and so what you're going to do is you're going to take that and you're going to take 324 plus 121 minus second answer, because it's already in your calculator, and you should get something like C squared equals 98.65 05 blank 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 blank. Now we're not quite done yet, because some people stop there, but understand we still have to take the square root of that. So second square root, second answer, and you get 9.93. So C equals 9.9 if we're rounding to the nearest tenth. All right. So we now have an opposite side and its opposite angle, and I'm just going to stop there, because at this point in time we just go back to the law of sines and work the problem just like that. All right. So at the bottom also you'll have a part where you have to find the area of odd-shaped or oblique triangles, meaning they are triangles without right angles. And so, but I have a couple formulas here and there for you to look at those, see if you can try to figure those out. And also on the back of your paper you have application problems, which you can also attempt. So give those things a try today. And as you know, I have the answers to these particular problems on the overhead, so you can look at those as you're working things to make sure you're doing things correctly. So have a great afternoon and a great weekend, and I will see you back on Monday. Please email me if you have any questions at all. Thank you, and have a, like I said, great weekend, and relax.